Today, we are diving into the foundation of data analysis. By the end of this lesson, you will be able to identify observational units, variables, parameters, and statistics, and distinguish between different types of variables. In any statistical study, we start with the who or what we are studying. These are our observational units. Think of an observational unit as a single row in a spreadsheet. If you are surveying students, each student is an observational unit. If you are testing the lifespan of light bulbs, each light bulb is an observational unit. Variables are what we measure or record about those units. A variable is a characteristic that may change from one observational unit to another. For a student, variables might include their height, their eye color, or their grade level. These values vary from person to person, which is why we call them variables. Now, let's look at how we categorize these variables. There are two main types: categorical and quantitative. Categorical variables, also known as qualitative variables, place an individual into one of several groups. Examples include hair color, zip code, or favorite music genre. Notice that even though a zip code is a number, it's a label for a location, not a measurement. Quantitative variables, or numerical variables, involve quantities where it makes sense to find an average. These usually have units of measure, like pounds, inches, or degrees Celsius. Let's look at this table to see the distinction. Notice the distinction. We don't average eye color, but we can certainly average weight. We've met our objective of distinguishing between these two primary types. When we deal with quantitative variables, we can break them down even further into two subtypes: discrete and continuous. This distinction depends on what values the variable can actually take. A discrete quantitative variable can take on a countable number of values. A discrete variable usually involves counting. Think of things that come in chunks. For example, the number of siblings you have. You can have 0, 1, or 2 siblings, but you cannot have 2.4 siblings. The possible values are separated by gaps. On the other hand, continuous quantitative variables can take on an infinite number of possible values within an interval. On the other hand, continuous variables are usually measurements. They can take on any value along a number line. Think of time. Between 1 minute and 2 minutes, there are an infinite number of possible moments depending on how precise your stopwatch is. Other examples include height, weight, or temperature. You can always add another decimal place of precision. By identifying if a number is counted or measured, you can easily determine if it is discrete or continuous. We have now reached our goal of differentiating between these two types of quantitative data. Now, let's talk about the big picture in statistics. We often want to know something about a huge group, but we can only realistically measure a smaller part of it. This brings us to parameters and statistics. A population is the entire group we want information about. A parameter is a numerical summary of that whole population. Think of the P in population and parameter to help you remember they go together. Parameters are often unknown because it is usually impossible to measure every single individual in a population. A sample is a subset of the population that we actually collect data from. A statistic is a numerical summary of that sample. Think of the S in sample and statistic. Let's visualize this relationship. For example, if we want to know the average height of every teenager in the world, that average is a parameter. Since we can't measure everyone, we might measure 100 teenagers. The average height of those 100 teens is our statistic. Notice an important point. The value of a statistic is often not exactly equal to the population parameter. However, we use the statistic to make an educated guess, or an inference, about what the true parameter might be. We have now met our objective of identifying the difference between parameters and statistics. Let's wrap up by applying everything we've learned to a real-world scenario. Imagine a biologist is studying the health of a local lake. In this study, what are the observational units? The individual fish are the units from which data is collected. Now, let's identify the variables and their types. Weight and length are continuous because they are measurements that can take on any value. Health status is categorical because it labels the fish into groups. Suppose the biologist calculates that the average weight of these 50 fish is 2.4 pounds. This is a statistic because it describes the sample. The biologist's true goal is to understand the average weight of all the fish in the entire lake. This is the parameter. We don't know its exact value, but we use our statistic of 2.4 pounds to estimate it. You've now mastered the basic vocabulary of AP statistics. You can identify who is being studied, what is being measured, and whether we are talking about a small sample or the whole population. Great job!